Hi, welcome to the second part in this Easy Composites video tutorial series. In this video, we'll be taking the pattern that we made in the previous tutorial and producing this three-piece split mould from that. Let's take a look at how it's done. When making a multi-piece mould, it's very important to choose the right location to split your mould. In this example, there are a number of features on the pattern which will help us to determine the best places for these splits. Looking at a pattern like this, you might think that the obvious place to split this mould would be straight down the centre line here. However, in this case, there's a couple of features that mean we can't do that. We have a scoop in the top here and also a scoop in the bottom section here, which would mean that the part would get mechanically locked into the mould. So that isn't a possibility. We've also made this pattern with completely parallel sides, which means that we can't just put a simple split line around the perimeter of the part there, because that would make the removal of this pattern from the mould and subsequently the removal of the part from the mould more difficult. You should always try and avoid parallel sides wherever possible. So that leaves us with the option of producing a three-piece mould. Now we're going to do this by creating a mould to produce the top section of the pattern with the parting line on the radius. A parting line on the radius is very easily disguised in the final part and polished out, so that's always something that, if you can, put it on a corner. And then we're going to split the bottom part of the mould in two pieces here and here, which will allow it to be easily removed from these parallel sides. Now that we know where we're going to split the mould, we need to secure a barrier around the perimeter of that split line. So effectively, what we need to do is create a support structure to hold the barrier firmly in place all the way around the part. So to do that, I'm just going to use some cardboard and roughly profile out that shape of the split line, adjust it as necessary. You can see we're just looking to adjust this profile in until it meets the line where we want the parting line to be. So we're just transferring the templates out onto some MDF, which is a bit more substantial for mounting the barrier onto. Okay, so we're just going to secure these down onto the baseboard using hot melt glue. With the support made, we're now going to make the barriers themselves. We're going to be using polypropylene sheet. This has excellent self-release properties, which means you don't need to put a release agent onto it. It also has a very smooth and consistent finish, which will make for very neat flanges on the moulds. Other materials that you might want to consider: fluted signboard. We've used this in previous videos for making barriers. It's very cost effective, very easy to work with, but it doesn't leave quite as smooth and consistent finish as you get from the polypropylene. So before committing to the barrier material, we're going to make a rough template using cardboard. Cutting a series of snips into the cardboard and folding it back to get the rough shape makes it very quick and easy to get a rough template. By using masking tape around the edge, you can get it to very closely follow the contour of the pattern. This is a really quick and easy way of getting a very accurate template, so just continue with a series of small pieces of tape until you've got the profile truly represented. The next job is to transfer this template onto a piece of polypropylene. This will become the final barrier. We're just going to draw around with a marker pen, nice and accurately following the line. I'm scribbling out this area here just to remind me when I'm cutting it that that's the side that's going to be lost. Using a jigsaw cutter, very carefully and as accurately as you can, follow the profile, and then all that's left to do is clean up any burrs around the edges. A Stanley knife scraping down the line will take off this burring very quickly. So we'll have a quick test fit of the barrier. It all looks good. So before we secure this down, we're going to apply the release agent to the pattern. The release agent is an absolutely vital stage in ensuring that the mould will release from the pattern properly. We're following the application guidelines for Easy Release Chemical Release Agent, which is to apply 5 applications, 15 minutes between each, and leaving that for an hour before applying any gel coats. With the last coat of release agent applied, we're now going to secure the barrier onto the frame that we've created. What we're going to do, so this isn't under too much strain, is warm the polypropylene up, which will allow us to bend it into a preform, meaning that it won't be under as much stress when we fasten it down. I'm just going to use a marker pen to give me a reference for where I want the bend. And then just go over it with the heat gun on a reasonably hot setting. The polypropylene will soften quickly, and that's all that's needed to be able to just bend the sheet around the edge of the bench here to give it the shape I need. With the barrier preformed into the contour, we're just going to use a high quality double-sided tape to attach it. I'm also just going to attach an end barrier on here. I'm going to use hot melt glue for this. The barriers are now secure all the way around, nice and substantial. So the next thing to address is the small gap that we've got between the barrier and the pattern. You can see, despite trying to fit this barrier to the pattern as closely as we could, there's inevitably going to be small gaps around, and all we've got to do is seal that using filleting wax. Now, filleting wax is very pliable. You can use plasticine for this operation, but plasticine really does make the job a little bit more tricky as it doesn't stick to the parts quite as well. So we'll just go all the way around the part, not being too careful initially, and then we'll clean this up and bring it into a nice 90 degree at the end. And what you're looking to do when you come to clean this wax down is get it level with your barrier. Now to do that, just using a wooden stick, carefully drag along with the stick flat against your barrier, and you end up with the filleting wax filling in at 90 degrees to the pattern. That will lead to a very nice joined seam line on your final moulds. You can clean up any areas where the wax has just been rubbed out by the scraper just by wiping it over with a block of wax, and it lifts the excess off, and then just using a clean lint-free cloth, just clean up the other areas, being careful not to drag the filleting wax out of the gap. With the barrier attached and sealed to the pattern, we're almost ready to gel. But what we need to do is create a system that will allow the mould parts to lock together and mesh together so that they align perfectly. There's a really simple little trick to doing this. So the method is, just take a small ball of the filleting wax, press it onto the surface, and taking a knife blade, just cut at 45 degrees down, making a small pyramid shape, like so. So we'll continue to apply these registration dots around the perimeter of the part, approximately every 200 millimeters and about 50 millimeters away from the edge of the pattern itself. Now we have the barriers sealed to the pattern and the registration dots in place, we're now ready to gel coat. We're going to be using the Unimold tooling gel coat, which is catalysed with an MEKP catalyst, which does require thoroughly mixing in. Then we're just going to brush this evenly and consistently over the surface of the pattern and the barriers. It's always a good idea to have a quick pinch at the bristles on your laminating brush to remove any loose ones which could spoil your mould surface. Getting a really good surface finish on the mould requires a reasonably thick gel coat, so the tooling gel coat can be applied either as a single thick layer or two thinner layers. On a mould like this, a single thick layer might be difficult to apply without the gel coat draining off the steeper sections and pooling at the bottom, so we'll be applying two thinner gel coats. We're going to leave this gel coat to cure for several hours now. In this instance, we will be putting a second gel coat application, but we do need to make sure that the gel has cured to a good firm tack. It's important not to apply the second gel coat too early. Of the three stages, the gel coat is by far the slowest to cure, and even when using 3% catalyst, it can take up to overnight for the gel to be ready. Always wait until the gel coat is almost fully cured before regelling or applying the coupling coat to avoid damaging the surface of the underlying gel. We're going to leave this second application for several hours once again to get to a tack-free state. Now we've got to attack free state with the second coat, we're going to move on to the coupling coat, like we've done in many previous videos, using 2 layers of 100 gram chop strand mat. The coupling coat resin is once again catalysed with MEKP, and we just brush this resin over the surface of the part before putting the chop strand down. This ensures that the resin is intimately in contact with the gel coat. It's very important to do this stage as accurately and precisely as you can, ensuring that all air voids and bubbles and pockets are removed just by stippling the surface. With this cured to a tacky state, we'll now proceed with the Unimold tooling resin and 4 layers of 450 gram chop strand mat. So once again, we will catalyse and thoroughly mix this resin. Then this will be brushed down onto the back of the coupling coat. You can apply this quite thick and thoroughly because the 450 gram chop strand consumes quite a lot of resin. Once the mat has been thoroughly wetted out, it's a case of stippling it and using a roller to ensure that any air pockets are driven out of the laminate. Then you repeat this a further 3 times to build up the full 4 layers of reinforcement. With that laminated, we're going to leave that once again for several hours to cure. As you may have seen in other videos which feature the Unimold system, the Unimold tooling resin will change from a darker brown to a cream colour as it exotherms and cures. With the first half of the mould now fully cured, we're going to carefully remove it from the barriers without releasing the mould from the pattern. So we can see that barrier has left us with this flange. Now that is the parting position of these moulds. The small wax pyramids that we made are still there, but we're just going to scoop those out so that when we create the next section, that will follow the contour in the opposite direction, creating a lock between the 2 parts. Also here, this filleting wax, we're going to need to just clean all of that out, and we should be left with a very crisp 90-degree line with the gel coat. If it's not perfect, that doesn't really matter because whatever line that has followed, the next parts of the mould that we're going to create will also follow that exactly. You can see that it's quite important to leave your pattern in the mould itself because that means that this flange here is perfectly sealed to it. We're now finished with this barrier and support frame, and we're going to continue to make the remaining mould sections. Now, if this was a 2-piece mould, which it isn't in this instance because of the parallel sides, we would just apply release agent to this, gel coat it and create the other side of the mould. In the case of a 3-piece mould, we have to repeat this process once more. So we'll be applying barriers onto this flange and creating 2 separate halves that separate in the middle here. It is vitally important that we apply a full multiple coat of release agent onto this, as it hasn't had any release agent previously. The pattern itself we have already coated, but at the same time it causes no harm in applying further applications there, and also if any of the release agent's been scraped out from where we've been removing the wax, it'll ensure that we get a good release at that parting line there. With the release agent applied, the next step is to produce the barriers to produce the next part of the split mould. In the case of this mould, we want an aperture in the bottom here. So I've shaped this PVC foam into the final profile of the aperture. This could just as easily be MDF or wood. As the gel coat would stick to the PVC foam, I'm putting some release tape down to ensure that we get a good release. And then here I'm just going to reapply the barrier onto the front of the mould using some double-sided tape. The procedure to produce the barriers for this central split, much the same method as we used for the upper barrier, just using a rough cardboard template and then refining it using masking tape. With these profiles made, they're now ready to be transferred onto our barrier material, which is polypropylene. So we'll just outline those templates and then cut them out using a jigsaw. With the barriers cut to profile, we're going to temporarily secure these in place using double-sided tape and some blocks. You can see here that the barrier doesn't perfectly follow the profile of the pattern. This won't be a problem. We can drive some filleting wax into that void and that will fill it and seal it against the surface. With the filleting wax in place, all that's left to do is to dress the wax neatly between the barriers and the pattern itself. Unlike the aperture barrier, these barriers, for the split line down the middle of the mould, need to be filled against the pattern with a sharp 90-degree finish. Registration marks are applied between these two parts because we want the lower halves of the mould to lock together in just the same way that we do with the top half. With all these temporary barriers secured into place, we're going to produce the next section of the mould in just the same way we did for the top part here. So we're applying the gel coat over the flange of the first part of the mould that we've already made, and then over the barriers that we've created to create the central split line. Again, trying to get it as even as we possibly can, making sure we don't miss any spots at all. We're now going to leave this for several hours before applying the second application. The point it needs to get to is the point where it'll still feel slightly tacky on the surface, but if you try and indent your nail in, it won't leave an impression. With the gel coat cured, we're now moving on to the coupling coat. Again, inspect it very, very closely and ensure that all air pockets have been stippled out. Having left the coupling coat to cure, we're now going to move on to the 4 layers of 450 gram. It's a really good idea to have these pre-cut and ready on hand. That makes the laminating and the layup that bit easier and quicker. It's very important when you're working on a more complex shape like this to pay extra attention to the corners and thoroughly roll it out, making sure that you don't have any large voids or air pockets underneath it. With the second section of the mould now cured, we're going to move on to the third and final section. To produce the final mould section, we need to remove the 2 polypropylene barriers that create the central split location and then clean out the filleting wax between the flanges and the pattern and also the indexing lugs. Don't forget that these newly created flanges will require a full multiple coat release agent application. I'm sealing the aperture barrier to the pattern with a round fillet of wax. This will provide a smooth corner on the mould in this location. Laminating this mould section is exactly the same as for the previous parts, which is 2 coats of Unimold tooling gel coat followed by a coupling coat with lightweight 100 gram chop strand mat, and finally the 4 layers of 450 gram mat with Unimold tooling resin. When working with resins, it's important to ensure that your workshop temperatures are appropriate. The optimum is between 18 and 25 degrees Celsius. If it's too cold, the resin systems can take much longer to cure, and this can sometimes even lead to the gel coat attacking the coating on the pattern. If the temperature is too high, the resin will cure too quickly, vastly reducing working time, and can lead to distortion and imperfections on the mould. Now that we have all 3 sections of the moulds made, we're going to mark up to drill holes which will allow the parts to be bolted together, and we're also going to trim off the excess off the flanges here into a nice neat finished mould. It's very important to do this before removing the mould sections from the pattern. You can see here that there is a slight bulge in the laminate. This indicates where the locating lugs are. You should aim to mark and drill bolt holes between these lugs. The excess flange material can be marked up to be trimmed. Do this well beyond the position of the lugs. For the main trim, I'm using an angle grinder with a slitting disc. This can be done just as well using a hacksaw, although it will take a little bit more time. The flange of the mould should be sanded with a block to ensure that it is completely free from sharp edges and splinters. This not only makes the mould safer to handle, but also reduces the likelihood of the vacuum bag being punctured during processing. For lots more information on ways to trim and cut composite materials, check out our cutting and shaping video for in-depth advice on technique and safety. With the mould drilled and trimmed, all that's left to do now is separate it from the pattern. To do that, we're just going to carefully prise it open using a chisel and a mallet. It's important to get it between the two layers of gel, and you can often just see a small crack. And next, we just split the two lower parts of the mould in just the same way. And we should be able to remove the pattern from the last section, like so. So here we have the completed mould set. You can see the accuracy that we've got on the split line there, and also the quality of registration that we get from these indexing lugs. This mould is now ready for use. That's the end of this video tutorial. You now understand the techniques required to produce complex split moulds. In the third and final part of this video series, we'll be taking these moulds that we've produced here and taking you through step by step and showing you how to produce this ultra lightweight prepreg carbon fibre airbox.